Hi, I'll be going through the umpire process for check array formation through concatenation. So for the understand step, so the input, so we're given R, an array of distinct integers. And we're also given pieces, an array of integer arrays. And then for our output, we just want to return true or false. If we can form R by concatenating arrays in pieces in any order, but we're not allowed to reorder the integers in each array in pieces. So for an example, if we're given if our input is R equals 15 and 88, and pieces equals 88 and 15. So we have two arrays. Then our output should be true. Output should be true because we can just add 15 first and then 88 like it says here. So if we're given, our input is 49, 18, and 16, and pieces equals 16, 18, and 49, then our output should be false because we just have one array, 16, 18, 49, and we can't change the order of the array, although it's the same numbers. And then we have one more array. No, we have one more example. So if R equals 91 for 64 and 78, and pieces equals 78 for 64 and 91. We want to return true because we can add 91, then 4 and 64 are in the right order, and then 78, and we have matching list or arrays. So yeah. So in terms of matching, I don't think I've seen this problem before, but I've worked with arrays, so arrays, lists, like matching problems. I think we would have to also use like a map or a dictionary. So I would say maps for this problem too, but I don't think I've seen a solution that I could use here exactly. So for the plan, the plan, I would create a map. So create an empty map, and then iterate over pieces, and then have the first element of each array in pieces equal the array it's part of in pieces. So we have our key being like so if we have, so maybe a better example would be this problem. So if we're iterating over pieces, so we have 16, and 16 will equal 16, 18, 49 because that's the array it's part of. Then after that, we can create an empty list. And then we can iterate over R. And then we check if the element is in our map. If it is, we add the array to our list. Then we'll just check to see if our list and R are matching. Okay, so for implement, so just create an empty map. So map, and then so we'll iterate over pieces. So for I in pieces, then we'll just have the first element of each array equal the array in our map, right? For map I0 equals I, and then we can have an empty list, or just put like new list equals, we're creating a new list, right? And then we'll iterate over R. So for J and R, if J is in our map, then we just want to concatenate the array to our list. So new list plus equals map and then J. Yeah, so we'll iterate over R, and then if J is in our map, then we'll add the array that number corresponds with to our list. Then we just want to return if our list equals the array. So let's run it. Yeah, so we'll get all the test cases, then submit. Yeah, so looks like it works. I just, yeah. Nice, so looks like it works. And then for evaluate, so I believe the time is O n squared, because we're using two loops. And then it's gonna depend on the size of our of pieces in array, right? Like the longer that our inputs are, the longer the solution will take. Then I believe space is also O n squared, because we have our map, and then the space that our map takes up is gonna be longer depending on how long pieces is. And then also our empty list will also be the space our empty list will take up will also depend on both of our lists, both of our arrays, or yeah, both. It will depend on array and pieces. So thank you. That's my solution for check array formation through concatenation.